is all about factoring. We want to factor everything into its simplest form. Okay? When we factor everything into its simplest form, it means I literally can't take anything else out of it. Okay? So we're going to talk about 3 different types of factoring today. And then tomorrow we're going to add a couple different ones into it as well. Okay. This is just normal standard factoring. I have x cubed, I have 2x squared, I have minus 15x. Is there, so when I go to factor, I always want to ask myself first question is, can I take something out of all 3 of those numbers? Or variables. Can I take something out of all? I can take an x out. So if I take an x out, I have x squared, I have 2x, and I have minus 15, correct?
Yes.
Now, is this factorable? Does something multiply to give me negative 15 and add to give me 2?
No. Wait, you said multiply.
To give you negative 15 and add to give you 2. Think about factors of 15. What are the factors of 15?
You can do 3 and 5.
Yeah, 3 and 5. You're right.
Wait.
Which one's negative? Which one's positive? Yes, negative 3, positive 5. Good, Drew. Now, I've factored it as far as I can. Okay? That's factoring completely.
Okay.
That was pretty simple one. What about up here? 2y to the 5th minus 18y cubed. Can I take something out of all of that?
You take a 2y cubed.
I can take a 2y cubed out. So if I take a 2y cubed out, I'm left with y squared minus 9. Ooh, what is this?
That's a difference squared.
Yes, a difference of squares. So how does that automatically factor?
Y minus 3 squared.
Nope.
No,
Y
y
minus
equals
3.
Negative 3, y equals plus 3.
Yes, and y plus 3. Y minus 3, y plus 3.
Group, you know what? I was here.
Hey, he's the one that noticed it was different in squares. Group effort. Okay, good. So we factored that completely. Now, down here, 4z to the 4th minus 16z cubed plus 16z to the squared. What do I do?
You take 4z squared.
4z squared.
A lot of z's.
Which leaves me with z squared minus 4z plus 4, yeah?
Mm-hmm.
Is that factorable?
Yes.
Okay.
Because wouldn't it be z plus, or no, z minus 2?
Z minus 2 what?
Squared.
Yep. So I have 4z squared, and then I have z minus 2 squared, correct? Because when I multiply negative 2 and negative 2, I get positive 4. And when I add negative 2 and add negative 2, I get negative 4z. Boom, beautiful. Okay, that is just normal factoring, stuff we've done in the past, but we just got to be able to continue to look at it. Remember, I always say, first step is, can I take anything out of this? That's always our first step, no matter what we're doing. Okay? There are some special factoring patterns. Now, these you have to have memorized. Okay? There is the sum of 2 cubes, and there is the difference of 2 cubes. So if something is cubed, now here's the deal. I have a cubed plus b cubed. When I break that down and I factor completely, I'm going to take a plus b, and then I multiply it by a squared minus a times b plus b squared. With numbers, it looks this way. 8x cubed plus 27. So here's the deal. You have to realize that this number here is a perfect cube and that this number here is a perfect cube. So if you see something written with just these 2 facts, like an x cubed, a z cubed, and it has a leading coefficient in front of it, and it only has a constant, I would check and see if they have cube roots.
No, they don't.
If they don't, then I might just be able to pull something out of them. But it might not be factorable either, okay? But if it's set up in this, just the constant and the leading coefficient one, I need to check to see if they're cubed, okay? So then I'm taking the cube root of 8x cubed. The cube root of 8 is 2. The cube root of x cubed is x. That's what goes in that A spot. Now the B spot is the cube root of 27. The cube root of 27 is 3. This spot here is this squared, 2x squared. So I get 2 squared, which is 4, and I get x squared, which is
X
x squared. So I get 4x squared. This spot here is just this times this. 3 times 2x, 6x. But it always has a minus if it's a plus. Okay? And then this last spot is just this squared. So I get.
So if it's minus, it'll be
difference.
So if it's minus, it's minus here, but these are all plus.
Okay.
Okay? If it's plus here, but this one's minus.
It's kind of that pattern.
Yes.
Plus, minus.
Yes. So down here, difference of cubes is a cubed minus b cubed. So once again, this spot is my a minus my b. This spot is my a squared. This spot's my ab. This spot's my b squared. 64x cubed minus 1. This one always gets people because 1 is a perfect cube. Okay? So people get confused on that because they're like, it's a 1. What do I do with that? Well, the perfect cube of 1 is 1. So I take the perfect cube of 64, which is 4. And I take the perfect cube of x cubed, which is x. So I get 4x. I take the perfect cube of 1 and I get 1. 4x minus 1. This spot here is this whole thing squared. 4 squared is 16. X squared is x squared. 16x squared. This spot here is this times this. 4x times 1. 4x. And this
Wouldn't it be
spot,
negative one?
No.
She said because
the pattern for difference of cubes.
it's
Negative, positive, positive. The pattern for sum, positive, negative, positive. Okay? Because on this one, I need the middle to cancel out. On this, I'm already canceling out because I have a negative here. Okay?
So people confused because they don't think 1's a perfect.
Cube, and they'll just stare at it and say it's not possible. And I'm like, yes, it is. 1's a perfect cube. So don't get tricked up when it's a 1. Okay? Now, look here. X cubed plus 64. I notice that this is a cube, so I'm going to ask myself, is 64 a perfect cube?
Yes.
What is it?
4.
Yes, 4 times 4 times 4. Right? Mm-hmm. Okay, so what goes in my first set of parentheses here?
X.
X, and then plus 4.
Or
Okay. What goes here? A squared, so it's this squared.
So
X squared.
X squared. And then here I have a minus. And what do I do with these two numbers for this?
You multiply.
Yep, so I get
4.
4x. And then the last thing here is what?
You squared.
I squared 4, which is
16.
beautiful. I factored it. Okay? The only way to factor these ones are to memorize them. There's no way around it because I can't sit there and pull anything out of those. You get what I'm saying? Okay? So you have to have that memorized. That's why I say that. Okay, now look at this one. Remember I said first question we should always ask ourselves is, can I take something out of this?
Yes.
Okay, what can I take out of this?
You take out a z squared.
A z squared. Nothing goes into 16 and 250?
I'm pretty sure it does. I should know.
No.
Yeah, think about it.
Wait.
250 is a
It's
even number,
Even, so it can be divisible by 2.
and 16 is also a even number. So let's take out a 2z squared, okay? So what would be left here? If I take a 2z squared out of this, what's left?
Maybe 8z cubed.
Good. And if I take out a 2z squared from here, what's left of this?
125.
125. Okay. Now I need to look at this part. Is this a perfect square or a perfect cube? I'm sorry.
Yes.
Yes. Is this a perfect cube?
Yes.
Okay. So what comes in my A spot?
It'd be 8.
No. I gotta take the
Oh, no,
cube
no,
root of
2.
8.
2.
2 and the cube root of z cubed. So 2z minus what's the cube of
5.
125? 5. Now I'm squaring this part here. So what goes here?
2z's.
2.
No,
4z
4z squared. Yeah, remember to square both portions of it. And then I have a plus sign. And then what goes here?
10x. Or 10z.
10z. Yeah, 5 times 2. 10z.
That's it.
And no, and
And
then
you square it, yeah.
yeah, and I get
25.
now I've factored that the whole way.
So with those that you have to take out, if there's two different exponents, it's gonna require like this one extra step.
Yes. Yep. Okay. And like on this one, right? We took something out and then it was a difference of squares. Okay. And on this one, we took something out originally, right? And then so difference of squares, and so yeah, it's the same concept, but this is sum of two cubes, difference of two cubes. Okay. On these ones, when you see four things, 1, 2, 3, 4, 1, 2, 3, 4, you have to factor by grouping. You cannot do it any other way, okay? I can first start always by saying, can I take something out of all of this? The answer is no, because this doesn't have an x with it, and this doesn't have a number that's a leading coefficient, okay? So I'm going to do something called grouping. I'm going to take this set and put it together in parentheses. And I'm going to take this set and put it together in parentheses. Okay, I'm going to group them together. Now, what can I take out of here?
You can take out an x squared.
I can take an x squared out, and I'm left with x minus 3. Okay? Now, here's the deal. I want to take enough stuff out of here that what is left says x minus 3. So that means I would have to take out a negative 16, right?
Yes.
What is 48 divided by negative 16?
Oh, 3.
So I get negative 16 and I get x minus 3. These are the same, yes? Okay. So because I grouped and broke things down, and I get the same thing here, which they have to be the same for this to work, okay? I'm going to combine these to make them into one thing, like this.
Okay.
And I'm going to take this and combine it now. Okay? That's the next step. Now, look at this. X squared minus 16. What do you know about that?
That's a difference of 2.
Difference of,
2 squared.
yeah, of 2 squares. Difference of squares.
So then it'd be x minus 4x plus 1.
Beautiful. And that is that whole thing factored out. Okay? These have to be the same. If they are not the same, you've done math wrong, or it cannot be factored. Okay? And then they become 1. Just like when I take the square root of something, I take one of those out. Yeah? Not both. Okay? Okay. So down here, I'm going to ask myself first, can I take anything out of all of this?
No.
No. So I'm going to group. What can I take out of x cubed plus 7x squared?
X squared.
And I'm left with x plus 7. So what should I get when I take something out over here?
You should get a positive.
Yes, and I should get, it should say, this set of parentheses should also say,
X plus 7.
okay. So in order to do that, I have to take out a,
Negative 9.
what is 63 divided by 9?
7.
Beautiful. So it works out perfect. Yes? Now, I combine these two, right? X squared minus 9. And then I have x plus 7. What do you notice about x squared minus 9?
Just the squares
Yep, so I get x.
plus 3 x minus.
Beautiful.
Doesn't matter what order you do it in, like with the x plus 3, x minus 3.
Nope, doesn't matter. Okay.
But the x plus 7 has to be in the back.
No, you can put that in the front too, doesn't
Oh,
matter.
right.
I just do it because I think in my head I combine those and then I just combine that. It makes it, in my head, that's how I
That's fine.
see
So,
it.
that should be, that seems